Now let's look at third problem. The third problem gives a cubic polynomial and gives us the 4 points through which it passes. So since we have 4 points and we have 4 unknowns, it can be easily solved. So let's put 0, 1 into this equation. If I write the polynomial as y equals a x cubed plus b x squared plus c x plus d. So let's put 0, 1 in this. We have 1 equals to 0 plus 0 plus 0 plus d. So we got d to be 1. Let's put minus 1 minus 2 here. So minus 2 equals minus a plus b minus c plus d, which is 1, or minus 3 equals minus a plus b minus c. Let's say this is equation 1. Now let's put 1, 2. 2 equals a plus b plus c plus 1, or this can be written as 1 equals a plus b plus c. Let's say this is equation 2, and let's put 2, 9 in this equation. So we'll have 9 equals 8a plus 4b plus 2c plus 1, which can be written as 8 equals 8a plus 4b plus 2c, or let's divide by 2. 4 equals 4a plus 2b plus c. Call it equation 3. Now we have to find 3 unknowns a, b and c. So let's first add equation 1 and equation 2. We have minus 3 plus 1, which is minus 2, equals a cancels, c cancels, 2b. So we'll get b to be minus 1. We got 2 unknowns and we have to find 2 more. So let's do this. Multiply equation 2 by 2 and subtract this from equation 3. So if you do this, we will have 2 times 4a minus 2a, which is 2a, 2b minus 2b, which is 0, c minus 2c, which is minus c, and here 4 minus 2, which is 2. Call it equation 4. Now let's subtract equation 1 and 2. So let's do this. Minus 1. We will have 1 minus minus 3, which is 4, a minus minus a, which is 2a, b minus b, 0, and c minus minus c is 2c, or 2 equals a plus c. Call this equation 5th. Now simply solve these two equations to get a and c. If you add these, you'll get 3a equals 4, which implies a equals 4 by 3, and from equation 5 we have c equals 2 minus a, which is 2 minus 4 by 3, which is, so we got our unknowns. C is 2 by 3 and a is 4 by 3. Okay, so now let's look at the fourth problem. The fourth problem says if a function fx in the domain x belongs to 0, 2, a closed interval is such that fx equals mod of x minus 1 plus mod of x square minus 2x, then we have to find the minimum and the maximum value of this function in the interval 0, 2. So let's see how to do it. So first let's see what is x minus 1. So x minus 1, if you plot this is 1, from 0, 2, this is 2. So x minus 1 is a function like this, and at 2 the y-axis is 1. This is x minus 1. And x minus 1 mod is, simply flip it around the x-axis, and in 0, 2 domain it is like this, a v-shaped function. And let's see what is x squared minus 2x. This is a parabola which has root at x equals to 0 and x equals to 2. So if we draw this, so the parabola is something like this. If you take the mod of this, it just gets flipped around the x-axis. So flip this portion around x-axis. This is the modulus of x squared minus 2x. So if I draw fx, which is given in the question, the function would look like this is 2. The sum of this x minus 1 mod, this is 1, plus x squared minus 2x mod. So fx is sum of these two functions, which you can see intuitively would be something like, it would have been some maximum here, then some perhaps some minimum here, then this and then this. Roughly it would look like this. So how to find the actual maximum and minimum of this function? So in figure you can see that fx is sum of these two parts, and if we move to the right from the origin, this part is falling and this part is rising. So fx, which is the sum of these two, is either falling or either rising, depending upon the fact that which one of these is falling faster or rising faster. So to find that out, let's look at the slope of these two curves at x equals 0. So slope of this line is simply x at x equals 0, the slope is minus 1. And to find the slope of this parabola, we simply differentiate it, x squared minus 2x, which is 2x minus 2, and the slope at x equals 0 is minus 2. Remember, this is the slope of the parabola. You have to find the slope of the modulus of the parabola. So simply flip this or take the negative of this original slope, which is 2. So this curve, slope of this curve is 2, and the slope of this curve is -1. So obviously this parabola is rising faster than how faster this line is falling. So effectively, if you draw fx, fx at x equals to 0 is 1, and it is rising from here. At x equals to 1 is 0 plus the value of parabola at x equals 1, which is say x squared minus 2x mod. At x equals to 1, this is 1 minus 1, 2 mod, which is 1. So again at x equals 1, fx is 1, and again at x equals 2, fx is 1, and fx is symmetric about x equals 1, which is evident from this figure. So intuitively we can say that fx is rising and falling to touch 1 again, and then rising and then falling again. So we have to find the value of x where it attains its maximum. Let's call it x0. X0 is the point where the slope of this curve is equal to the slope of this curve. So at that point, the rise in this part is equal to the fall in this part, so that the net effect of these two is 0. So at that point, fx would achieve its maximum. So the slope of the inverted parabola is minus d of dx of x squared minus 2x, which is minus 2x minus 2, which is 2 minus 2x. So when this will be 1, that is the rate at which it is rising is 1, which is equal and opposite to the rate at which this line is falling. That point would be x naught. So x equals, if you solve this, 1 over 2. This is our x naught. Simply, since the function is symmetric, this part is 1 plus half, which is 3 over 2. So fx achieves its maximum at x equals half and 3 by 2, and fx is minimum at 0, 1 and 2. X equals 0, 1, 2. So the maximum value of fx is f at half, which is nothing but half minus 1 mod plus half squared minus 2 times half. This is half plus 1 over 4 minus 1. This is half plus 3 over 4. So 3 over 4, and this is 5 upon 4. And the minimum value of fx is 1, which is clear from this picture.